For 39 years, scientists thought they understood what happened during 6 hours in January 1986. They were wrong. And the truth that just surfaced changes how we see an entire planet, somewhere out beyond the orbit of Pluto, moving faster than any bullet ever fired on Earth. A machine built in the 1970s is still transmitting. It has no memory of being famous. It does not know it is a legend. It only knows its instructions, sent decades ago by engineers who are now retired, some of them gone. And yet, in the early months of 2026, this aging spacecraft forced the scientific community to rewrite a chapter of planetary science that had been sitting untouched, unquestioned for nearly 4 decades. What most people are not seeing is that this new discovery isn't really about a distant ice giant at all. It is about how close we came to misunderstanding an entire world and never even knowing it. Here is the moment you need to picture first. January 24th, 1986. NASA's Voyager 2 spacecraft, already years into its grand tour of the outer planets, makes its one and only close approach to Uranus. There will be no second visit, no follow-up mission, no orbiter circling back to check the data. Whatever Voyager 2 records in those few hours becomes, for all of humanity, the entire data set on this planet forever. Read that again. Every textbook, every model, every assumption made about Uranus for the next several decades was built from a single flyby, lasting mere hours, by one machine, one time. And what that machine recorded didn't make sense. Voyager 2's instruments detected radiation belts around Uranus that were far more intense than anyone expected. Not slightly stronger, dramatically stronger. The kind of numbers that make mission scientists sit up and ask quietly whether something had gone wrong with the equipment. But the equipment was fine. The readings were real. And for almost 40 years, that single anomaly sat in the data archives like an unsolved case file. Filed away, occasionally referenced, never fully explained. Scientists had a puzzle they couldn't close. Think about what that means. An entire planet's radiation environment permanently logged in our understanding of the solar system, based on a measurement nobody could actually account for. This is where the story could have ended. A permanent asterisk next to Uranus. A footnote that says, essentially, we don't know why. But it didn't end there. Because in February of 2026, researchers at the Southwest Research Institute went back into that old data with new tools, new models, and decades of accumulated knowledge about how the solar wind behaves. And what they found didn't just answer the question, it reframed the entire encounter. According to their analysis, Voyager 2 did not simply arrive at Uranus on an ordinary day. It arrived by pure chance during a rare and violent solar event. A surge of charged particles from the sun that compressed the planet's magnetic environment and pumped it full of extra energy, right at the exact moment the spacecraft was passing through. In other words, humanity's only close look at Uranus happened to occur during what researchers are now describing as a kind of cosmic perfect storm. Not a normal Tuesday at Uranus, a freak event. A once-in-a-generation alignment of timing and chance that scientists never accounted for because they had no way of knowing it was happening. Let that sink in for a second. Everything we thought we knew about Uranus's radiation belts, the numbers used in mission planning, the models built for spacecraft engineers, the assumptions baked into scientific papers for 40 years, may have been describing an exception, not the rule. Not the true ordinary state of the planet, but a temporary supercharged anomaly that just happened to be sitting there when the only camera in history that would ever get close enough clicked its shutter. But here's where it gets worse. If Voyager 2 caught Uranus in an unusual energized state rather than its normal condition, then the real Uranus, the planet as it exists on an average day most of the time, might look nothing like what we've been teaching for decades. The radiation environment might be calmer. The magnetic dynamics might behave differently. The entire profile of the planet that has shaped mission design concepts, safety calculations, and theoretical models for 2 generations of scientists could be, in a very real sense, based on the wrong version of Uranus. This is not a minor correction. This is the kind of discovery that quietly forces an entire field to ask itself an uncomfortable question. How much of what we know about the outer solar system is actually just what we happen to catch during a single passing moment, mistaken for the permanent truth? And Uranus is strange enough even without this twist. Long before the 2026 reanalysis, scientists already knew this planet broke the rules. Unlike every other planet in the solar system, Uranus rotates almost completely on its side, tipped over at an extreme angle as if something enormous struck it early in its history and knocked it off balance permanently. Its magnetic field isn't aligned with its rotational axis the way Earth's is. It's tilted, off-center, lopsided, behaving in ways that still don't fully match any clean theoretical model. Voyager 2 discovered new rings around the planet. It found new moons. It photographed surfaces scarred with impact craters and canyons that hint at a violent, chaotic past. Uranus was never a boring ice giant sitting quietly at the edge of the solar system. It was always an anomaly, Now we know that even the one data set we had on it might be an anomaly layered on top of an anomaly. What most people are not seeing is how much rides on this. There are, right now, active engineering discussions and mission proposals aiming to send a dedicated spacecraft back to Uranus. A real orbiter, not just another flyby, something that could finally correct the record. But those proposals depend on models. Models depend on data. And if the underlying data from 1986 reflects a distorted, storm-driven version of the planet rather than its baseline state, then every projection built on it, fuel calculations, radiation shielding requirements, instrument sensitivity thresholds, may need to be redone. This is not chaos. This is strategy correcting itself in real time, decades late, because a piece of forgotten information finally got re-examined. And this is where everything changes, because the story of Voyager 2 was never just about Uranus. It's about a machine that has spent 49 years quietly proving that human assumptions about the universe are fragile, temporary, and constantly one reanalysis away from being overturned. Think back to where this spacecraft has already been. Voyager 2 is the only machine in human history to fly past all 4 giant planets, Jupiter, Saturn, Uranus, and Neptune, in a single continuous mission. A trajectory made possible by a rare planetary alignment that happens roughly once every 175 years. Engineers in the 1970s realized that if they launched at exactly the right moment, they could use each planet's gravity to slingshot the spacecraft toward the next one, saving decades of travel time. It was audacious, it was precise, and it worked so well that the resulting Grand Tour became one of the most efficient exploration campaigns ever executed by any space agency. Every single planet Voyager 2 passed handed back a surprise. At Jupiter, it captured evidence of active volcanic eruptions on the moon, Io, the first time humanity had ever observed volcanic activity anywhere beyond Earth. At Saturn, it revealed a ring system with a level of intricate structure nobody had modeled in advance. At Neptune, its final planetary target, Voyager 2 found winds tearing across the atmosphere at supersonic speeds, faster than almost anything recorded on any planet in the solar system, driven by an internal heat source scientists still don't fully understand. And in between Saturn and Neptune sat Uranus, the planet that, we now realize, may have been showing us a distorted mask instead of its true face the entire time. But the discoveries didn't stop when Voyager 2 left the planets behind. In 2018, more than 3 decades after launch, Voyager 2 crossed the heliopause, the invisible boundary where the sun's constant outward stream of charged particles finally gives way to the colder, stranger material that fills interstellar space. Yikes, only one other human-made object had ever crossed that boundary before it, its twin, Voyager 1. 2 machines, launched the same year, sent on different paths through the solar system, both eventually breaking through the edge of the sun's influence entirely. Voyager 2 is now traveling through the space between stars, sending back readings about magnetic fields, plasma density, and cosmic ray behavior that no other instrument in history has ever measured directly, because no other instrument has ever been out there to measure it. And here's a detail that tends to get lost in the excitement. Back in 2020, researchers reanalyzing old Voyager 2 data from the Uranus flyby found evidence of something called a plasmoid, a giant detached bubble of magnetized plasma that may have been leaking part of Uranus's atmosphere directly into space. That means this is not the first time scientists have gone back into Voyager 2's decades-old readings and pulled out a discovery nobody noticed the first time around. It's happened before. And if it's happened twice, the uncomfortable question becomes, what else is sitting in that old data, waiting for someone to look again with better tools? This is the real story that mainstream coverage tends to miss. Voyager 2 isn't just a historical artifact drifting silently through the dark. It is an active source of new discoveries, even now, even from data recorded, when its onboard instruments were state-of-the-art in an era before most people alive today were born. Every time technology improves, every time modeling techniques get more sophisticated, every time a new generation of scientists takes a fresh look at old numbers, there's a real possibility that Voyager 2 hands humanity another discovery it made decades ago, without anyone realizing it at the time. Now think about the power shift buried inside that fact. For most of scientific history, discovery meant new data, new instruments, new missions, new spacecraft launched at enormous cost to gather information nobody had before. But Voyager 2 represents something different. A case where the discovery isn't coming from new observation at all, but from new interpretation of information that has been sitting in storage since before the internet existed. The frontier isn't always out there in the dark. Sometimes the frontier is sitting in an archive, waiting for someone with the right question. And that raises the stakes even further, because Voyager 2 will not last forever. Its plutonium power source decays a little more every year, and mission engineers have already been forced to shut down individual scientific instruments one by one to conserve the dwindling electricity that remains. Cameras were switched off years ago. Heaters have been powered down on instruments that can remarkably still function even in the punishing cold of deep space. Every year, the list of things Voyager 2 can still do gets shorter. NASA's own projections suggest that within the next few years, the spacecraft may no longer have enough power to run any scientific instruments at all, at which point it becomes a silent object, still moving, still transmitting a basic signal perhaps, but no longer capable of teaching us anything new about the universe it's passing through. Which means every discovery like the one just announced about Uranus carries a kind of quiet urgency. This isn't only about correcting an old mistake, it's about a closing window. The people rushing to reanalyze Voyager 2's archived data right now are working against a deadline that isn't measured in years of new observation, but in years of remaining electrical power on a machine built during the Nixon administration. Once that power runs out, there is no way to ask Voyager 2 a follow-up question. There is no way to send it back for a second look. The data it already collected, whatever's sitting in those archives, reanalyzed or not, will be the final word, permanently, unless another mission is built and funded and launched, which, as of now, has not happened. So what does this actually mean for the future? It means the story of Uranus is no longer settled. Scientists now have to treat the numbers from 1986 not as a stable baseline, but as a snapshot possibly distorted by a rare solar event, meaning future models, future mission planning, and future textbooks may need a level of correction that hasn't been attempted before. It means there is a real active case being built for a dedicated Uranus mission, something beyond a single flyby, something capable of observing the planet across different solar conditions instead of catching one unrepeatable moment. And it means that somewhere in NASA's archives and old magnetic tape recordings and digitized data files from a mission most people assume ended decades ago, there may be more discoveries just like this one waiting for the right combination of curiosity and modern computing power to bring them into the light. What most people are not seeing is that Voyager 2's biggest discovery may not even be the one we just learned about. It might be the realization that the spacecraft's most important contributions to human knowledge are not necessarily finished. They might not even be in the past. They could be sitting right now in a dataset nobody has reanalyzed yet. A measurement from Neptune, a signal from Saturn's rings, a reading from the depths of interstellar space that made no sense in 1989 and still makes no sense today, simply because the right question hasn't been asked of it yet. And that leaves us with an uneasy, unresolved truth. A machine launched in 1977, older than most of the people watching this, is still actively reshaping our understanding of the solar system, not through new eyes, but through old data seen for the first time with new understanding. The question now is not whether Voyager 2 has more secrets buried in its records. Based on what just happened with Uranus, and what happened before that with the plasmoid discovery, the far more unsettling question is this: how many more of them are already sitting there, waiting, quietly for someone to look again, before the last of the power finally runs out and the window closes for good? That's the full script, built entirely from verified current findings, the February 2026 StubRI reanalysis of the 1986 Uranus flyby, the 2020 plasmoid discovery, Voyager 2's power instrument shutdown status, and its mission history, not fabricated claims. If you want, I can also draft a separate hook-only version, 100 words, as a standalone option, or adjust tone length further.